Okay, good. So I didn't want you to come on the podium because we are moving to the second panel. And as in the first panel, the guy said that IC is alive and kicking, and now are the electrician coming up. I didn't want to be in the middle in the battle between the IC and the electrician. So please welcome Huber Friedl of AVL that will moderate the second panel towards the car electrification. I move away before the ICA guys come back. Thank you.
Okay, thank you. Okay, ladies and gentlemen, let's come back into the world of electrification again. My name is Hubert Friedl. I'm from AVL headquarters in Graz. So I'm in charge to be product manager for gasoline engines. So I'm coming from the world of internal combustion engine. And honestly saying, in the first two speeches, keynote speeches, definitely was a little bit scared about the progress, about the change. Probably. But there were some discussions in between and some presentation who brought us back to the ground again. So anyway, I'm still very motivated to come back to electrification. So I kindly would like to invite the panelists for this presentation. So I start with you, Corrado Nizzola, who is in charge to be senior manager from DAIMLER for electrification and hybrid system. Then Alberto Bisoni, please come up, director of control systems at General Motors here in Turin. Then there's one third person coming from an OEM. It's Lucien Koopmans from Volvo Cars. He's director of advanced in engineering. Hello, Lucien. Then we have four more people coming from supplier. So first I would like to ask Alexander Fiersching from BOSCH. Alexander Fiersching is Senior Vice President for Control Systems of Electrification. Thank you very much. Then further Italian company, Magneti Marello, it's Ignazio Dendici. Hope I spell it. He's innovation manager for electric system and also for the architecture of electric system. Then furthermore, Volker Hansen from EM Motive. EM Motive is a joint venture of Bosch and Daimler, and he's a managing director of EM Motive. And last not least, Mr. Katsune Hayafune from Midec from Japan. He's Senior Vice President and General Manager for Automotive and Electronic Control. So the podium is very full, so many people, and for this discussion, we have a little bit changed the format, so I extensively have squeezed all the participants to really cut their contribution, their presentation, to give more time for discussion. And at this point, I also would like to ask you in the audience really to raise your questions and your ideas. So in this respect, I really would to point out and to appreciate the work of the ladies. They are continuously working here. I think this is definitely a super day, yeah. So you really have to mention how many hours they are constantly working on this. This is for me. This is like painting Michelangelo in the Peter's Dome. So spending several months. So they are standing and the artist was lying. But I think definitely this is a great idea to put the ideas and all the thoughts to the panel. And I expect most of you are able to share these ideas and the questions and the statements and things like that. And for me, I expect all of you have generated a lot of idea, and potentially there's some pop-up valve required in your emotion or in your brain, really to release your ideas, whether you see it from this side or the other side. But anyway, the topics we have discussed today is quite very controversy. So we still have the feet on the ground. We have the uncertainty. Nobody knows what the future will bring in this respect. Will it be just internal combustion engine? Will it be battery electric vehicle? Probably not the one or the other. So as mentioned before, we definitely have many different shades of gray in between, and at the end it's the customer who decides what potentially is the right solution. I think the uncertainty we are facing now generates a huge pain to the industry. I think this is the point, because we are diversifying, so we heard it in last presentation, and the industry has to provide all the solutions more or less at the same time. The numbers where they can make the return of investment, the profits, is very, very low. So this requires probably a lot of patience to wait until the return of investment comes again. Anyway, I think we should not waste or lose too much time. So I would like you to start first. To give your, is the presentation already loaded? Yeah. So I kindly ask you to start.
Thank you very much. So I speak now about technology trend. I don't speak about market penetration, something like that. I just want to show you, in our opinion, how is moving the technology on hybridization electrification. What you can see here is a very good slide that I use always to show the degree of electrification. You see on the left side the conventional powertrain, 100% power from combustion engine. On the left and the right side, you see 100% of electric power from electric motor. And between you have all the degree of electrification, hybrid, plug-in, and so on. Now look about today. Today we are starting now to have a small electrification between 12 and 48 voltage. And please don't say 48 voltage is equal to mild hybrid. What we will see in the next day, in the next year, the first generation of 48 voltage, BSG, with power between 8 and 10 kilowatt, is for me not an hybrid. This is a better alternator. Hybrid started with a minimum at least 15 kilowatt, and then we speak about hybrid. And depending of voltage, high voltage, 48 voltage, but 15 kilowatt we need for a hybrid propulsion. Everything less than then is a better alternator. We have today PHEV plug-in with electrical range 30, 60 kilometers. Here the focus is to drive a combustion engine and to drive local emission-free. And we have also battery electrical vehicle with electrical range between under 50 to 100 kilometers. Of course, premium more than 400 kilometers. This is the state of the art today. The next step in the development, you can see here, is really that 48 voltage with increased power will be the future hybrid. And I believe that a hybrid powertrain is the best efficient way to use energy for driving, because we have recuperation, and considering well-to-wheel energy use, then we have really a less CO2 emission. This is very good way to use energy, fossil energy to drive. Plug-in, they will move in direction more electric range. If the customer have to drive more electrical, then want to drive more electrical with a lot of power. It means increase of electrical range, increase of power. And in this case, the electrical power will be more the combustion engine power. And of course, for pure electric vehicle, the electrical range will increase to 500 kilometers, and of course, also the power will increase. And now for the colleague of combustion engine, don't worry, because everything that we heard today, we spoke about 25% of electrical car, something like that. It means that we still have 80% of combustion engine. It means we will need you, but maybe the combustion engine will be different. First of all, you have to accept in the plug-in, future plug-in powertrain, that the master of power will be the electrical motor, and a combustion engine will be less power. Maybe you have to understand that for battery electrical vehicle, will have so many power that no combustion engine can have the same feeling to drive, the same acceleration. And so I think will be the future, even from the point of view of technology development, but also from the point of view of customer. Customer in premium segment, they discover this fun to drive, they discover this electric drive, and they want to drive this kind of powertrain.
Okay, thank you. Thank you. So I would like to hand over to Lucien Koopmans from Volvo Car Corporation.
Yeah, thank you very much. So
Thanks,
I'm from
Lucien.
Volvo. The guy who's on the picture, he's just a driver. Anyway, a couple of months ago, actually, our CEO and boss, Håkan Samuelsson, he made a bold statement, and he said that in 2025, we will sell 1 million electrified vehicles. We will have been sold that. And that's quite a bold statement because we are a quite small company. We sell maybe 500,000 vehicles today and this year, hopefully a little bit more. But that also means that, so 1 million is quite a lot. But that also means that when having sold 1 million, that also means that we have sold 8 million internal combustion engines by 2025. And we have only 3 platforms there. So we cannot stop developing them as well. We need to look at the system as a whole. So this is a picture of a hybrid system, as I see it. It's a combination of an internal combustion engine and an electrical motor. And we have to look at the system itself, to combine the two, to use the two, to have them work as a team. Optimize the internal combustion engine in the area where we cannot use the electrical motor. And then I think we will have a system that has an extremely good prospect on very, very low CO2 and emissions without any compromise, like the range we have all talked about. Except cost, of course, because that's what we have to work on. And that will be our big challenge. Why are we looking at electrification? You can tell us. Now, it's actually legislation that forces us to do it. If you look at the picture here, you see CO2 on the x-axis and the amount of energy required to operate on the driving cycle on the y-axis. And for heavy vehicles, like in the EG segment, subs and large vehicles, on the VLTP cycle, it requires an efficiency of about 40 to 50% of the powertrain system. No internal combustion engine can do that today, especially except for big truck engines. So we need a combination of the two. But this legislation is only tailpipe CO2. We look at tailpipe CO2. There's no well-to-wheel consideration. The electrical powertrain has 0 CO2. There's also no alternative fuel credits. For example, HVO, that's a biofuel, hydrogenated vegetable oil, is diesel equivalent CO2. There's also no LCA, life cycle analysis consideration. That means that if you look at the manufacturing of a battery, only a 24 kilowatt hour battery will give you an equivalent of 33 grams per kilogram CO2 calculated over 150 kilometers. 150,000 kilometers, sorry. The Tesla has a battery of 85 grams kilowatt hours. You can do the math. So, that might change. Politicians, we know they sometimes change their view and their way of thinking. And then I'm thinking about this other vehicle, and it's a V60 operated on CNG. Only the CNG gives a big reduction in CO2. If I look at biomethane, it actually is solving another problem, and that's waste, global waste. You can gasify it, you get biofuel, biogas. It's only 38 grams per kilometer. I think that's also a very alternative solution, if the politicians change their mind.
Okay, thank you, Lucien. Yeah. So we come over to the established Tier 1 suppliers organized it in that way. So Bosch and Magneti Rimarelli, so we may say they are still living in both worlds, so in the conventional combustion engine world as well in the electrification world. So we are looking forward to hear your statements on the future propulsion technology.
Friedel, thank you so much to giving the opportunity today to have such a beautiful round of OEMs and suppliers to talk about the future of the car automotive industry. Before I thought we can already skip this session because everybody was so enthusiastic about internal combustion engine that there's no more need to talk about electrification. Nevertheless, I think it's very clear that it's not an either or. And we as Bosch, as the biggest automotive supplier, of course, want to be in both worlds, and we also want to continue with the internal combustion engine. But we hope that time will give us some more time to enjoy internal combustion engine and develop electrification. Because if you see what is the picture I'm showing here, is basically a future car. It's not a Bosch car because our task is to enable OEMs to make a future car, but it's a connected car and it's an electrified car. And I think it's very important that all in the audience, they already talked about it, that the future will be connected, automated, and electrified. So that's things which go along quite well, and therefore we think also that electrification will come, but it will not be 100%. It will be, like we heard in 2030, 25%, so still 80% for the internal combustion engine. And that's, at the end of the day, of course, a question, who will drive this? And as I'm not an engineer, but an economist, I think a bit also about the macroeconomic effects, and you see what are influencing factors. You see that cities, so I lived 10 years in Asia, in Tokyo and Shanghai, and in Shanghai definitely the pollution is so bad that we will have to have a solution on this. And it's not important whether this is the most efficient solution to go for electrification, and even if you have coal power plants, it's still for Beijing, Shanghai, and the mega cities a local solution which will be driven by legislation, and therefore it's a topic we cannot ignore at the moment. And of course, we have new players coming in. So in China, we just have the situation that we have about 80 OEMs, new OEMs, who also want to build electric cars. And the government now made a release of a new law that restricts the electric vehicle makers to only 10, with very strict requirements to R&D, production, and so on. So my message is, please look a bit wider, not only to the technology or engineering. Of course, you are engineers, you like your engineering, but nevertheless, macroeconomic and also political issues will play a major role, which we should not ignore. And as I'm economist, last not least, the cost will be the decisive factor, because especially in Asia, we have a lot of people who first time buy a car, if they buy one. We heard that many don't want to buy a car anymore. And therefore, here I think this is very well describing the situation. What is the tipping point for electrification? And it's, of course, emotion to have a roaring combustion engine, but at the end of the day, cost is driving the budget of families, and they will think about, if you look to the black lines, it's a diesel, which is still more expensive than a gasoline car. So here we see the cost of the powertrain, and we see that in 2025, the tipping point will come, so the blue line of a battery electric vehicle will touch ground with a diesel, and in 2030 with a gasoline powertrain. And with a budget-restricted family will decide what is my most beneficial car. They will certainly think about the cost situation, and the tipping point will then lead to a decision what is more cost efficient, what is more beneficial of using in a big city. And last not least, we have our vision for the e-mobility, And we say, as Bosch, we make the world enthusiastic for e-mobility. And I think also engineers are very excited about their engineering topics, but the e-mobility is really fun as to the acceleration, and also if you feel 80% acceptance we heard before of first-time drivers, this will really make the future more bright for the electrified cars. And of course we have the vision to make the best electric car of the world in combination, in cooperation with some OEMs. And last but not least, as I'm an economist, it must be affordable and economically viable. That's why I really want to have you all in the boat. We will have internal combustion, but electrification will definitely come.
Okay, Alexander Birsching, thank you very much for this comprehensive view. So I would like to hand over to Magneti Marelli, to Ignazio Dendici. Probably he has a very specific view on the situation, or probably similar as Bosch do.
Yes, so good afternoon to all. I'm giving you today an overview of how, with electrification needings, CO2 needings, also the role of the component supplier is changing in the scenario of the automotive market, and which are the two main, I would say, target for an automotive component supplier. There are to switch from a components level to a system level, and also to drive the innovation for the electrification of the car. Okay, so in this first slide you see which is the main system and products of Magneti Marelli Powertrain. Magneti Marelli is working on engine control units, so in powertrain, both gasoline and diesel. He's working on transmission, and he's working on electric system and general electrification. This gives us the possibility to see, together with the roadmap of the electrification, also what is happening on the transmission and on the engine side. And this gives also the advantage to look at the vehicle at a system and not only to the components level. This, we see, is an advantage even when we talk about the portfolio of electrification for us. We work for sure on 48 volts component, and I fully agree with Mr. Nizzola's statement about 48 volts, because when we talk of 48 volts, we don't have to talk only about mild hybrids, we don't have to talk only about 10 kilowatts level of power, but we have also to step up to 15, 20 kilowatts that gives higher benefits both to the OEM, but also to the final customer for the car that has a driving experience and a good benefits from drivability from this 48 volts low voltage technology. And for sure, among all the other components that we provide, that the market asks for us, I want to highlight about powertrain electrification and energy management, because once again, this means that we have to approach the system, at the system level, the vehicle. So looking at the components as a component itself is not anymore enough in the automotive market today due to all the needings in CO2, in drivability, and in pollutant and emission reduction. I want to show our e-motor roadmap, because once again, together with the permanent magnet induction machine, BSG, there are well-known components in the market. I want to highlight about the last two topics on the right upper part of the slide, where you see powertrain, electronics and control actuators, electrification for the powertrain, and high-speed e-motor. This comes from two main drivers today in the automotive market. The first one is that the increasing of the electrification of the powertrain will also give the possibility to enter in the vehicle not only with the traction system, but also with today hydraulic actuator that will switch to electric actuators. And also the level of the voltage that we have on the actuators, electric actuators, will reach to higher voltages to increase efficiency. That is exactly what today happens in the racing. Today in racing, you have only one high voltage battery, especially in World Endurance Championship and Formula One, and you have a lot of DC-DC converter and a lot of intermediate voltage level to manage the efficiency of the car. That's exactly what is going to happen in the car passenger vehicles in the future. And the last one, there is a high-speed motor, is to show you that today, talking in the next future to electrification, you cannot anymore talk about modularity and scalability of the components, but you have to look to the fully integration of the component in the vehicle. And integration in the vehicle means increasing efficiency, and one of the ways to increase efficiency is to increase the speed of the motor. Because maintaining a constant power, if you increase the speed, you have a smaller dimension, smaller weight, and this means higher efficiency for the vehicle. And finally, the last slide is a focus on 48-volt system, once again, in which I want to highlight that, once again, 48-volt system cannot be thought anymore only like mild hybrid, so only as a belt starter generator integrated in the engine, but they can be thought as a traction system, because it's from 15 to 25 kilowatt, it's feasible as a mechanical power, is already demonstrated. There is the electronics, there is the capability, there is the technology to drive this innovation. And once again, approaching it as a system, there is the possibility to increase the overall efficiency of the vehicle with this technology that in the mid-term, it's really promising for the electrification of the vehicle.
Okay.
That's it.
Mr. Dendici, this was very compressed summary, so I think this was also a good guiding over to the next point, to the electric machine. I think also the electric machine has plenty of duties to do. So I ask Volker Hansen to point out his point of views on electric motor.
Yeah, thank you very much for having me. And now we come to the heart of it all, right, the electric machine. But I'd like to say one thing. Electrification, and I've never experienced a roundtable where so many ECI people were scared of their jobs. Electrification is a team effort. It's all about working together, and I think this conference is beautiful in discussing this. And E-Motive is one example of working together. It's a joint company of DAIMLER and BOSCH, and together with an OEM view and experienced supplier, we're trying to build up on the electrification. So just a couple of few on our portfolio. E-Motive is working on so-called separate motors, which are for electric vehicle. We're working on IMGs, which are hybrid engines, and for sure we're working on ISG, and as you pointed out, Corrado, the real 48 volt, which is giving more than 15 kilowatts. Yeah. Okay, that's our portfolio, and how are we working on this? We're basically trying to build a modular approach to it. That is on the development and pre-development side, working together with our mothers, and then also on the series development side, we're trying to modularize the engines as much as possible to create scale. Because at the end of the game, it's all about power, and I'd like to discuss power a lot, even though we are always faced with the challenge of making no sound at all. Yeah. But it's all about power, and it's about cost, and quality is just a given thing. Yeah. So modularization is the one way to reduce cost, and that's how we work in E-Motive. We have the same ideas about the tipping point for sure. We see a roadmap which goes from hybrids to plug-in hybrids to battery electric vehicles, but they're all going to be there at the same time, so complexity is going up, and we need modularity to fight that. So it's all about getting modularity engineered into the products, and it's all about adjusting production to deliver multiple engines from the same line and to create scale effects. So with this said, I'm very happy to be here to discuss where should electrification go, how fast should it go, but I'll always be very happy to discuss shared specifications and overlapping efforts to really build on a modular approach. Otherwise, we're going to all die the cost challenge in the electrification. Thank you.
Okay. Thank you, Volker Hansen, for this presentation. So, and I would like to hand over to Mr. Hayafune. Yeah. So, your company is very famous in producing electric motors since a long time in all the different sizes. So we even more interested to hear your perspective from Japan and on a global scale.
Thank you very much for my introduction. And my name is Hayafune. I'm coming from NIDEC Corporation. NIDEC Corporation is the electric motor manufacturer in Kyoto, Japan, not Tokyo. And thank you very much. It's my honor to be here. This is my first time to present here. But I don't know why I am nominated as a panelist. Thanks for the Loccioni, Mr. Loccioni. But I welcome the electrification world because I'm a motor supplier. So probably all these guys are related to the ICE world guys. And honestly speaking, I worked for the car OEM for more than 20 years. And after that, I'm working for the motor supplier. But I must sell my product. So I welcome the electrification world. But we want to change the discussion here because this panel discussion is almost the same as the previous one currently. But this discussion must be electrification. So we must concentrate on the electrification. So, I must say that the electrification world is totally different from the ICE world because our competitor, the competitor is different from the automotive industry. Our competitor will be a kind of IT industry competitor, like Google, Apple, and Uber, and a Chinese very strong supplier, like Huawei. Their strategy is totally different. We must be careful. We must prepare for the future competition. Otherwise, we will be like a Japanese semiconductor or electrics industries situation. That kind of be very important for us to discuss. And this presentation, I am very much sorry. I do not prepare the technical presentation. The technical discussion must be done here, and this is my company's promotion. So that I will briefly explain my company. And our company is basically the 100% motor manufacturer. 23% is automotive motor. And we have so many motor-related products. And we will go into the powertrain and the drivetrain components. And finally, we want to develop the traction motor also. We have several automotive group company, and we will be a special motor-based supplier in the automotive. That is current our situation. But anyway, we want to discuss what is the electrification. This electrification world will come in the very near future. The time is very much limited that we must prepare. Thank you very much.
Thank you very much, Mr. Hayafune. So I think you have seen electrification is very efficient. So I think we managed all the key statements of the panelists in very a short time. So I would like to hand over to common discussion, and I would like to start with you, Mr. Bissoni. So out of your bio, so everybody knows you have been involved with diesel engines for a long time. So probably this is a good bridge to the electrification topic. And what I would like to ask you, how do you see the advantage of electrification? So especially diesel is suffering really from extensive requirements, from calibration, from the component side and things like that. For you personally, do you think this is, let me say, a big reduction of pressure when you do not have to fight with emission regulation anymore, because electric motor is much simpler to calibrate? You do not have to deal with all the worldwide emission regulation. Do you think this is one strong driver for more electrification?
Yeah, thank you very much for the question. I mean, it will be an interesting debate, the one that we will have here in this round table. And I really feel to be, from one side, part of the old, and from the other side, maybe part of also of the new. Not me myself, but maybe the people that are working with me, more part of the new, the young engineers. So I would start from, I mean, the colleague here, the panelist, was referring to a war. Before, during the first part of the evening, we heard conflicts, contradictions even between internal combustion engines, diesel in particular, as being the symbol for the old engines and the new propulsion systems. So my responsibility is diesel controls, by the way. That is by itself a contradiction, or leaves this contradiction being controls more on the electronic portion, and diesel still referring to this old and noble entity of the diesel. So I'm used to contradiction due also to my work. So I'm really welcome to talk about this. So the real point is there a real contradiction between electrification, autonomous driving? I'm now looking at this wonderful panel in front of us, and diesel and internal combustion. No, I don't think it is a contradiction. This is the real point. And I mean, we have already evidence of some of these examples. We have electrical water pump in our combustion engines, electrical oil pumps, many electrically assisted auxiliaries that somehow paved the way for a stronger electrification that will be unavoidable and welcome. So what's next? For sure, we will have a big step that, according to me, will be the revolution of the engine architecture, of the internal combustion engine architecture. That we may have internal combustion engines that will finally do their job for which they were designed, that is, providing torque to the wheels, and not refrigerating the passenger compartment because they are driving the air conditioner, or recharging batteries, because finally, up to now, batteries as always existing in the vehicles, and they were recharged by the internal combustion engine. So I don't think that will be a contradiction. It will be really that synergy that some of our previous panelists have already discussed. So if it is not a contradiction, what is for me electrification? Okay, for me electrification is for sure an opportunity, but it has one element, one factor that I would like to offer here to the auditors, that is complexity. We are adding another important actor in the generation of the torque to the wheels. So, and here is where also my nature of control guy maybe is coming and jumping on it. I mean, we are not scared of these new electrification actors that are coming over. We are willing to play a big role also to control this new system that is a much more complex system. We have to work together to simplify it. Otherwise, we all will be having hard times. And so simplification, in my opinion, and facing with the right tools the higher complexity that is coming with the electrification of the internal combustion engine, and that is bridging to the pure electrification, will be one of the key words. So long life to controls people, long life to internal combustion engines as well, when they will be properly electrified.
Very good statement. Thank you very much. So
when you said, okay, we make more complexity and so, but was also what you say, it's very important to simplify what we have. Maybe we have to stop to speak about electrification or to speak about combustion engine, whatever. We have to speak about powertrain. And whatever which powertrain we need, you say in China we need electrical powertrain, or some local application we need a pure electrical powertrain. For other application we need a plug-in powertrain. And then we are not speaking about complicated powertrain, we have to stop to make add-on technologies. And when I speak with the transmission people and they say, I need a transmission for my e-drive powertrain, and they ask me, okay, how many gear, 9 gear, 12 gear, how many clutch, 3 clutch, 4 clutch, and so high-end transmission people, engineering, we develop always the best one. And when I say I need only 1 gear, they say, oh no, this is not a transmission. You can buy wherever you want. Huh? And the same with the combustion engine. When they say, forget the turbocharger, because we have 200 kilowatt electrical motor. Oh no, no combustion turbocharging is not possible for combustion engine. And what I'm saying, we have to think about overall system. Maybe we have some example like Toyota, okay, but Toyota Prius, it's an overall system, no high-tech combustion engine, no high-tech electrical motor, but a good powertrain. Maybe not so beautiful to drive, but whatever, it's subjective. And for this reason, I think simplification of overall powertrain.
Okay, Mr. Bisoni, you, in this context, you raised 2 very important arguments. The one is architecture, and the other is electrified components. So this, so I'm looking to you, especially to Mr. Dendici. What is the current situation of supplying industry really to make progress in delivery of electrified components? So thinking for 48-volt system for the architecture and things like that.
Thank you for the question. Yes, that's exactly what we expect. Exactly what we expect, because what we see is that once that you have a storage at 48 volts in the car, and once that you have a very high level of power requested from the auxiliaries in the engine, there will be much more 48 volts components that will be integrated in the engine. And that's because simply you will have smaller cables, you will have a smaller level of currents, and immediately you gain efficiency on the system, immediately. Because if you increase the level of electrification and you increase the level of voltage, you can increase by the energy storage, you can increase by DC-DC, but in each and every case, you will gain efficiency of the overall system. And that's very important because the next generation of the powertrain that we will have, they won't be standalone components designed as they are today, so engine, transmission, e-motor, but each and every components of the powertrain will be sized exactly to be operative in a certain mission that is the system mission and not the component mission.
Maybe to add on an important component, which is the battery. So we feel that this is currently the major bottleneck to go ahead, and we are developing now with our partner in Japan, Mitsubishi and GS and also with next generation in California, Palo Alto, now batteries which have to fulfill above 350 kilometers to 500 kilometers, and a charging time of 20 minutes to 80% of SOC. And I think these are the major hurdles, because if people think a car must run more than 500 kilometers to be really on the safe side, and they don't want to bother with more than 20 minutes of charging time when you go to the Autobahn to a station. And this is technically at the moment not yet feasible, and therefore we also see the tipping point that the battery has to meet this target latest by 22, 23 to catch the wave for the tipping point.
May I ask complementary to my question before, what do you see next for this, especially for the 48 volt? What do you see next as electrified component? Is it just the water pump? Is it the oil pump? Is it the valve train electrified, the turbocharger, whatever? What do you think, or the brake booster, for example, what do you think, what comes next to be extensively introduced to the market?
Yeah, we expect 48 volt to come quite fast, however not for how long, because we see that in China there's a strong push, for example, for plug-in hybrids, that they should be introduced faster. So therefore, when we see 48 volt to start in 2018, it might not last much longer than 25. That's a danger. It might also last longer, but somehow nobody is sure about this at the moment.
Yeah. What you actually say, this is a certain kind of intermediate solution. It makes me a little bit concerned. So I would like to ask you, Lucien, so you are dealing a lot with life cycle analysis and things like that, and when new considerations come into the game, so when not only tank to wheel CO2 is considered, you already presented, if really well to wheel and lifetime analysis comes into game, do you think some other kind of hybrid configuration may become in a better position in this perspective of lifetime analysis?
Yeah, that's a good question. I think the electrical vehicle, the electrified vehicles, they can have one huge advantage, and that's zero tailpipe emissions. And that's why they are so heavily pushed by the politicians due to incentives and stuff. But I think they need to be competitive on their own. I think when the politicians start changing their mind and when they take into consideration well-to-wheel or LCA, yeah, then everything can happen. And so we still have to get the CO2 goal, and we still have to be concerned about our environment. So I don't know what's going to happen. It will definitely be a hazard for the electrified vehicle, as would be that the customer will not buy them because they are too expensive. So they have to be competitive on their own. We have to work on range, cost, and even well-to-wheel and LCA.
Yeah. But I think we all agree that this is not just an one-dimensional target to reduce CO2. It's very dependent on the boundary conditions and on the view how you perceive CO2 emission lifetime, CO2, whatever. It's very politically influenced from legislation. Okay. Anyway, coming back to architecture, so would like to ask you, so have you shown several solutions for electric motors. When we speak on mild hybrids, what do you see as the next level? What do you see as the highest potential? Whether shall we go ahead with belt starter alternator? Do you think the integrated starter generator has a certain chance? What do you see? Where does the electric machine is intended to go? Is it close to the engine, or does it work into the transmission, or even to the rear axle? What is your perception?
Yeah, I think it's all about, as you said, complexity, handling complexity, and at the same time handling integration, as integration is a major driver for reducing costs, right? And sort of we're navigating in a wide space of different possibilities of topologies, of regulators saying you have to do it that way, and maybe customers at the end having to buy the vehicle. So question is how fast you go with the integration and how much complexity you still leave, right? So our belief is here to go into a stepwise approach. We're sort of building up on 4 generations of experience of integrating hybrid engines in gear boxes of Mercedes. And we're now taking this experience to the next level as we're integrating electric engines with power electronics and gears for fully electric vehicles. And in this effort, it's all about meeting specifications, that is increasing power. And through generation 2, 3, and 4, we've increased power by 40%. And it's all about cost reduction, as I said before, and that's a team effort. And in these 3 generations, from generation 2 to generation 4 hybrid engines, we've been able to reduce cost by 50%. And I just can call on everybody here to keep the heads together and say, what's a sensible specification for the next electric vehicle, for the next hybrid vehicle, and how can we match this into an evolving building block of electrification, which can then be easily integrated.
Integration is important. Okay, I would like to come to another very important topic. This is charging. So from Nidec, so we have heard you really have an extreme wide portfolio of electric motors and things like that. I would be interested, is Nidec also considering to improve the ease of recharging the batteries? So first you told IT is really, let me say, the strong competitor of the classical automotive industry. But I think every one of us has experienced some pain with the mobile phone, with the smartphone. What happens when the battery is low? And I think this is really one very strong argument, which also may be, let me say, a support or enabler for more electrification, if the topic of charging can be solved in a very user-friendly, very convenient way. So is there any activity going on at Nidec company in this respect?
Yes, honestly speaking, I don't want to be such kind of a word, because the IT industry is totally different industry. So we don't want to introduce this competitor. But a certain portion of the automotive, the cars will be changed to the kind of only the mobility. That probably these guys want the large horsepower and the vibration and noise. But the kind of small portion, these cars remains as a small portion. Almost all major portion will be turned to the only the mobility. Especially Japan, the previous session, some guy is saying that in the graduate stage students, the half of the graduate students do not take the driver's license. And in Tokyo area, urban area, the car, the maintenance cost is very high. They don't want to own the car. They want to use as a mobility. So a certain portion will come as a commodity product. So in this case, the like smartphone is very much expensive. I cannot believe that this smartphone costs us $800. but my daughter is changing this every year. I cannot believe it. If this costs $800, I will have this product for more than 10 years. That is my common sense. But in this case, the IT lessons learned are kind of a de facto standard exists, de facto standard, like Windows. And number one supplier takes all. Number two supplier takes very little. Number third, nothing. Such kind of world will come. So, and in this case, the most important point for manufacturer, is developing or keeping the core component, the killer component we must develop and we must manufacture. Otherwise, we will lose the race. So as the motor manufacturer, we are developing the common requirement always come from OEM as a powertrain component. That is smaller, lighter, and cheaper also. So we always develop such kind of smaller, lighter, cheaper component. The technology for the motor is high efficiency electromagnetic circuit design and cooling system. These two technologies is very much important for us. So to win the race, we will develop such kind of a component. That is our strategy.
Yeah. So thank you very much. I like very much your competitive view on the situation. So Mr. Fiersching already took the microphone. Would you like to add something on this?
Yeah, just confirming and adding about the charging time, which was your initial question. And the charging, of course, basically, technically would not be so critical because 90% of the times the car's only standing on the parking lot. So from this point of view, there would be plenty of time to charge them. However, psychologically, people feel unease about this. So we feel we have definitely like wireless charging, think about these things to enable it during the standing times to charge it without really the people are being aware of it and just having as an integral part of their life, not going to a gasoline station, but if they go shopping to a supermarket, they have a wireless charging slot, and of course we need to develop the technology, which is not so far away, to just have the charging available everywhere and without special effort. And I think that's a key component also for the electrification.
So if I understood you right, so automatic, I call it automatic or contactless charging will arrive quite short term, if I understood you correct.
Yes, absolutely.
On a broad scale.
Yeah.
Yeah. Okay, that's very interesting. But so I'm a mechanical engineer, and even before I had a situation for charging the battery, but just for 1 hour waiting on the podium, my battery for the headset had to be recharged or replaced. And there's one element which came to my mind. This is range extender. So I'm looking to you, Mr. Netzula, out of a bio, I've read you have worked on a range extender. In the last time it got somewhat quiet on the availability on range extended. The question is the range extender, is it out of the game? Will the range extender compensate it really by high capacity batteries, or is there still a chance for the good old range extender?
It's a difficult question because first of all, you have to identify what is a range extender. In this case, I will understand a range extender like a small combustion plasma generator unit to charge the battery, but just if it's very empty. It's mean a serial hybrid. It's like BMW, for example, with i3, and without connection to the wheel. Thinking about that, like a limp home functionality, it's very difficult because at the same time the cost of the battery and the energy of the battery, the cost of the battery decrease very fast and the energy of the battery increase also. It means that it's easier to install more electrical range. And you see also the last update of the electric car, I say from Volkswagen, but also BMW. BMW now offering a base battery, then you can pay more, you have a larger battery, also big battery, or a range extender. And now will be interesting to see what is doing the customer. But for sure, a range extender can help the customer to buy an electrical car. Maybe it will use the electrical car, and it will see that in the range extender never use it, because always with 200 kilometer electrical ranges and out, and maybe the next one will buy a pure electrical car. I think a range extender is more psychologically, because just as the anxiety about the range anxiety, and to be afraid, and now I have, in the evening I cannot drive, I stay alone because the battery is empty.
Okay.
Yeah, maybe instead of range extender now, today we're more discussing long-range hybrids, plug-in hybrids, yeah, and where you got the full comfort of ICE driving, also the sound, but if you like, then you can have full electric driving for your daily driving routine. And I think it's all just depending on the drivetrain cost, but that's going to be the next step. Yeah.
Very interesting. Ladies and gentlemen, at this point, so looking to Kamini regarding the time. Anyway, so we really have a very inspiring, very intensive discussion. So I also would like to ask the audience, is there any very urgent question from your side which has not been covered up to now? I think today we have learned so many things about electrification, conventional combustion system. So please raise your hand. So if there is any urgent request for some question. Otherwise, I would like to come back to you again. Range extender. What's about fuel cell in this respect? So Daimler is very active also in fuel cell. How do you see this as an opportunity? Yes. Is it really the major source of?
Also in the past, the big motivation of fuel cell was the range with a fulfill and a very fast fulfill the fuel cell. In 3 minutes you can fulfill with hydrogen. Was a big motivation of a fuel cell. Today we will also have, or we will have also electrical car driving 500 kilometer electrical range and charging, you say, also in 20 minutes. It means that big motivation now in the short term to have a fuel cell is not here, because the big competitors now is electrical car. And of course, if you see, they have a lot of company make investment, research and development on battery cell. If you compare with the development on fuel cell, they have a big gap. It means that in mid-term, it will be for sure electrical vehicle, battery electrical vehicle, the most coming. But at the same time, also the fuel cell we are still developing. We will take also, we presented also GLC with the fuel cell. We also go into production, serious production, small production to have experience. But the big volume in short term, mid-term will be electrical vehicle. In long term, for sure, we have to think about energy. But the fuel cell with hydrogen makes sense only with renewable energy, and to build up the hydrogen with renewable energy.
So you raised also one important keyword. This is renewable energy and alternative fuels. And I always, when I hear alternative fuels, I always have to look to Lucien Koopman. I remember the time when we had a very strong hype on alcohol fuels, E85 in Sweden. And then when I look to Scandinavia, so all of us have heard about the situation, what's going on in Norway. So Norway plans to ban all the combustion engine. They give huge incentives for the battery electric vehicle. Of course, everybody knows, so Norway is a rich country. What is your perception? So look, let me say from the Scandinavian view on all these initiatives, on these local initiatives.
Well, the ethanol vehicles, that's a good example of that technology has to stand on its own, because that was also completely driven by incentives. People who bought the vehicle, they could have free parking and everything else. When that stopped, nobody bought the vehicle anymore, because they had shorter range, and the ethanol is actually, if you calculated it, almost as expensive as the gasoline. So people stopped buying them. At the moment, actually, we have Preem as a fuel company. They have 100% HVO for the diesels. So that's an initiative. But yeah, we can't count those CO2 credits, but that's 100% alternative already. I know. I think in the future it will be. We have to consider alternative fuels.
Yeah. Okay. Thank you very much. You mentioned one argument. It's the customer, and coming really to the customer. So we all have heard. So legislation is forcing us. We, being part of the industry, we follow this. We are brave. We follow this. We deliver the technology and things like that. But for my perception, who really cares for the customer? Because at the end, also in political election, there's only one right. This is the voter who is right, and in our terms of automobility, only the buyer is right. And so I would like to take this as a last round in our panel discussion. What is your personal view? What has to be done that really the customer at the end is really convinced that, I'm speaking of e-mobility, not whether less on hybrid, but what at the end convinces the customer to buy really highly sophisticated electric car? Does he find advantage? Does it find it sexy? Is it cool, this acceleration or whatever? But really, to take this as a last round of discussion, what do you think has to be done from technology, from infrastructure, whatever, really to promote the end customer? They say, wow, this is really a good choice. I do something good for environment, whatever. So may I start with you, Volker?
Yeah, I think it's all about creating customer value. I mean, Norway, I think, has invested, communicated 2.5 billion euros of not achieved taxes because of the incentivized, and they basically spend it all on Tesla, right? And I think Tesla was the first company who really created customer value in having a dedicated design, having an interface which really shows what's going on in the vehicle, and also integrating the whole charging mechanism into the look and feel. And I mean, if you step inside one of these cars, you really feel like you're part of the future more than being part of the past. And I think it's all about this, creating a driving experience which is really electric. And from a motor standpoint, I think it's all about having an electric motor that delivers torque, as more even torque than power. It's all about acceleration inside the cities. We've shown that with the Electric Smart, which is the fastest car on the first 5 meters, which is exactly what you need inside the city, on the turning light, on a traffic light turning to green. So I think it's about these customer experiences and promoting that you're part of the new thing. Yeah.
Thank you. Mr. Tendici, what is your view on that? What can we as industry do to promote electrification?
I think that the Tesla model is the first step on this electrification of the market, because it has demonstrated that can be fashion. An electric vehicle can be fashion, can be attractive, has performances, and can attack the premium segment. This can be the first step. The second step, in my opinion, should be create a CO2 culture, that it's not only dedicated to automotive, but it's something that it has happened on the cigarettes today. In the first afternoon, we were discussing about that with a keynote speech. And finally, the change of the automotive model with the sharing mobility will be maybe the final step to convince the people to use the electric experience as a day-by-day, daily experience.
Yeah, it's the appropriate combination.
Yes, the integration and the combination of the driverless technology, connectivity, electrification, and finally the model of the mobility that will change. These 4 main drivers, they are all interconnected, they are not standalone. So the final step will be maybe this integration of these 4 steps.
Yeah, thank you very much. Alexander Fiersching.
Yeah.
So we are all talking a lot about Tesla and building a Tesla fighter. So that's, of course, one important target. On the other side, we feel that we have different customer segments. And for example, in Japan, in Germany, but even in Shanghai, we have a problem with the aging population. And these people don't necessarily need a Tesla fighter. They rather want to have an automated electric car who can drive them wherever they want for limited urban mobility. And therefore, we see also this segment in the future to be very important, to have an electric car beyond 80 below 80 kilowatt performance, which is automated and electric and could give a real segment for elderly people who are normally have enough money to afford for it and want to be mobile. So I think we have to think about all these customer segments.
Mm-hmm. Thank you very much.
I fully agree. We have to look about the different segment because we have different customers from Smart or for Mercedes S-Class, and even from truck. Now we're starting also to think about electrification. We presented also electrical truck, and what we learned from Tesla, and we heard also this morning we saw the selling number, that for every new expensive technology you have to start top down, and first you sell the car to the people that want to have it, and then you make rollout and technology gets cheaper and cheaper, and then you can achieve also the people for normal price, for normal technology. Until this happens, then we have all the powertrain variation. 48 voltage is very for the volume, for sure. Not everybody can buy a Tesla, and then we have also customer buying a Smart and A-Class, and not everybody S-Class. And then we have all the degree of electrification and also of the cost for all the customer, 48 voltage, plug-in, and of course, electrical vehicle.
Okay, thank you very much.
Yeah, trying to stay very simple. I mean, range is no more a problem. This should be, according to me, one of the selling points, at least a reasonable range. We are no more talking about 50 kilometers. It's much more. And the second point could be fun to drive is no more diesel. Fun to drive is electric. Infinite torque at 0 RPM. This is the electrical motor.
It's a good statement. Lucien.
I think it's already been said, but I think what we have to do is we have to build cars that people want. Yeah. So reduce the hurdles, don't limit freedom, or just people. If they buy an electrical vehicle, they should not be concerned about things. They want to have their comfort and everything else. So I think we have to work on that. Limit the hurdles.
Just one comment to the top-down approach, which not necessarily needs to be the case, because we see, for example, for e-scooters, that the e-scooter is coming from bottom, very cheap, and these people then maybe also want to have a small e-vehicle. So that's, for example, in Shanghai, 100% combustion engine motorbikes were forbidden, and now we have 100% e-scooters, no more bikes in the land of the bike, which is China. So I think also from the bottom you can create some customer value.
We're approaching from both directions, but your argument is absolutely right.
Coming from the bottom, we had the experience with the Smart, and I think it's ideal electric car because moving only in the city, but the customer of Smart is not ready to pay so many money for a small car, because with the same price they buy expensive one. Up. But the scooter, okay. Maybe we are thinking about scooter.
Okay, Mr. Fune, may I ask your final statement?
Final statement? But, so the customer requirement is different depending on the region. But the all common requirement is a safe trip or safe mobility. This is very much common among the world. We don't want to lose our life during in the mobility. So this is most we must secure. So we must train or brush up our autonomous driving technology. Now after that, we must offer them the cheaper or cost-effective and efficient solution. That is my understanding.
That's a clear statement. Okay, ladies and gentlemen, I think this was really a tough final route. We are exactly in time, so you see electrification really proves to be highly efficient. Thanks again to all the panelists. Thanks to all of you for your patience. We have one person.
No. I was called to wrap up this day, which is almost impossible, but I had a substantial help from a guy called Aristotle, and so we'll take an Aristotelic view to the wrap up of today. So as we heard everything and the opposite to everything, Aristotle comes to play with us because he said that as each thing is made by two opposites, we're absolutely fine. The other interesting thing is that you will see in few minutes that the internal combustion engine is alive and kicking, and we are already enjoying shared mobility, because it will be a diesel bus that will take to evening and to lunch. Thank you, and see you tomorrow.